Okay, polynomials. So when we are going to talk about polynomial functions, a function that separates items with adding or subtracting, and it has to be a real number exponent. So you can see here the exponent is 3, 1, 0. Those are real number exponents. So you can't have to an exponent 1/2 because that's a radical, right? Okay, so first example, what is the degree of this polynomial equation? So it's a third degree. Why is it a third degree? It's a cubic. It's the highest exponent is 3. So the leading coefficient is 1 because it's 1x cubed. So number 2 is a fourth degree equation. And why? Because the highest exponent is 4 and the leading coefficient is 5 because it's 5x fourth. Next one is a sixth degree because it's the highest exponent. You notice how I don't care about the other exponents? I'm just looking for the highest. -4 is the leading coefficient. And what's the degree of the last one? I'm trying to be tricky. It is a second degree because that's the highest exponent I see. So the leading coefficient is 3. Okay, so I tried to be tricky. It's not what's in the front, it's about what's the highest. Okay, we're going to go up to 5 degrees of graphing. So 1 degree, you've already done that in grade 10. What did you graph in grade 10? When you graph just an x, what kind of shape does it make? A line. So it's called a linear function, the name of it. Two degree, x squared. You did this all of grade 11, so what's the name of that function? What is it called? The shape is called a parabola, but what's the name of the function? Quadratic, yeah. You're right on the shape, though. That's a parabola. Okay, x cubed. You haven't done it. Anybody want to guess what the name is? Cubic. X fourth we've never done. It's called a quartic. I always think of a quart of milk or a quarter of money, 4. And x5, and what's it called if you have 5 babies at one time? Quintuplets. What did you say?
You said 5-opolis.
5-op. Quintuplets. Quintic. Okay, so if you have a positive x, it will make a line that goes uphill. So this would go from quadrant 3 to quadrant 1. And if you have a negative x, what would it look like? It would slide going downhill. So this would go from quadrant 2 into quadrant 4. Okay, if you had a positive x squared, you should remember what it looks like from grade 11. Parabola, a U. So this would be from quadrant 2 to quadrant 1. And if you had a negative x squared, what would it look like? Upside down, reflected, flipped, right? So it would go from quadrant 3 to quadrant 4. Okay, I'm also going to make a little bit of a statement here. End behavior, does it make sense that my arrows go in the opposite direction? Right, both of these, they go in opposite directions. And what about the arrows on a squared? They would go in a same direction. They're both heading up or they're both heading down. Okay, cubic. Now our shape is going to be a letter N. Are we okay to state it's the same as number 1? Would that make sense to you? Right, the arrows are doing the same thing as number 1. So what would a negative cubic look like? Can you think about how to draw that? Okay, so you need to reflect that shape. I'm not going to rewrite it again. It's the same as the arrows on number 1. Okay, a 4th degree. It's also a letter of the alphabet. Not my applied people. Anybody else want to take a guess? No, you're not allowed to guess.
Are you dead?
What, or unless you forget. What? Is it an M? This one. This one is an M. So yep, you're right. This one is a W. Because the arrows have to go up, right? If it's positive, the arrows will go up. Okay, are you okay if I write the end arrows would now be the same as a second? And a 5th degree is a cubic, and there's a potential for it to have an extra bump.
Whoa.
That's wild.
Okay,
Pencil or what?
so the end behavior all depends if what's happening, if it's odd or even. Does that make sense? All the odds will do the same kind of end stuff, and all the evens would do the same end stuff. So end behavior, odd versus even, right? That's where the difference comes. Okay, so those are your foundation to the shapes. Okay, now we're going to talk about x-intercepts. Do you guys know that a root, these are kind of all the things that are meaning the same thing, x-intercepts, roots, zeros. Okay, so if this is a factor, what is the x-intercept? If this is the factor, the x-intercept is positive 2. So what's going to happen? You're just going to go through. Somehow you're going to be going through it. Okay, again, if the factor is this, the x-intercept is 2, but it's squared. So this time you're going to bounce. When you get to 2, you're going to hit it and bounce off of it. And this one has a 3 up here, so it's called a triple. So this time, when you get to 2, you're going to flatten through. You're going to get to a flatten, but then you're still going to go through, but it's going to flatten out like that. Okay, there you go. You know how to do 3/4 of the unit.
Cool.
Yeah. You need to understand the shapes and what to do.
Are we in our notes and stuff or no?
Yeah. Okay, so let's graph. Okay. First thing is, how many x's get multiplied in this scenario? How many x's would I get? I would have an x cubed at the end of this if I was to multiply, distribute, 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 x cubed. So now I know the shape is what letter? An N. Where are the x-intercepts? +1, -2, +3. And what is the y-intercept? So what is a y-intercept? The definition? When x equals 0. So if x was 0, this would be -1 times 2 times -3, which makes +6, right? Okay, so you can see my 3 x-intercepts and my y-intercept. And I have to draw an N through all those shapes, all those points. And that's it. That's all I expect of you. Some of you might have had this looking a little different here and here. That's okay. You don't know how to do that yet. For those of you in the calculus course, we will get more specific and we'll be able to graph that point and that point. But for now, that's it. You need your intercepts and your shape. Okay? Okay, number 2. How many x's get multiplied on this one? What degree would it be at the end of it all? Did you pick 4? X squareds in that one, more x squareds make x fourth. So it's going to be a W. Okay, so my x-intercepts are at 1 and -2. One and -2. Where is the y-intercept? Okay, so if x is 0, 0 minus 1 squared times 0 plus 2 squared equals the number
2. No, 6. 8.
go in the middle of your first two guesses.
Oh, 6. 4.
Negative 1 squared is just 1 times 2 squared, 4, right? Okay, now what does this mean on my x-intercept again? What does it mean when it's squared? It bounces. So I need to have a W shape. I need to do a bounce on this one, and I need to do a bounce on this one because they're both squared. So can you make a W shape that bounces, Okay, let's jump to the next page. So this one we're going to do. Okay, so how many x's get multiplied here? 1, 2, 3, 4. But there's a negative 2 in the front of all these getting multiplied. So it's going to have a negative 4th degree shape. So it's going to look like an M. Okay, do you see how I just pick out that general information? So where are the x-intercepts? Negative 1, positive 2, and 3. And where is the y-intercept located? Okay, so on this one I have this coefficient, so negative 2 times 0 plus 1 times 0 minus 2 squared times 0 minus 3. So I need a number on that. Is this number going to be positive or negative? Without your calculator. You don't have a calculator in your exam on this one.
Are you sure?
Why do you need, yeah, you don't need a calculator for that.
Sure, you know, buddy.
You can do it. You can do it.
I'm proud of you.
I give up.
Okay, positive or negative? Positive. Okay, we can do this. Ready? So there's a 2 here times another 2 and a 2. What are you up to now? 8. 3 is 24. See, no calculator. We did it. Okay, I'm just going to put 24. Okay, here's another thing I'm going to do. I already decided my arrows are both down, so I'm going to do this. Is that okay? To remind myself, my arrows need to be down on the ends. Once I get to the ends, they're going down. Do you have any weird things like bounces? Do you have any bounces anywhere? That was a double. So you're going to have to bounce off of that one. Okay, so cross through, bounce, cross through. Okay, last one that I'm going to graph, and then we'll do the just backwards a little bit. Okay, so this one has how many x's altogether? 4. W. X-intercepts are at 2 and -2. Okay, what is the y-intercept? So 0 minus 2 times 0 plus 2 cubed. Without a calculator. Okay, so don't forget, your arrows have to end up going up, right? Your arrow pattern at the end, that's kind of a reminder to yourself. Your arrows need to do that. Okay, can you tell me what's happening at 2? Just gonna go through. What's happening at -2? It needs to flatten. So it needs to flatten here. So what is it gonna look like? That's a flatten. So the W is just a little bit skewed and looking, but okay, we're gonna go backwards here. Okay, y equals some coefficient. Y equals some coefficient times a factor. If it has an x-intercept at -2, the factor is x plus 2. If it has an x-intercept at 1, the factor is x minus 1. And if it has an intercept at 3, the factor is x minus 3. But what did it do? What happened here? It bounced. So you need to put a square there. Okay. Now, what I need to do is I need to figure out what is going to be in this A position to cause this to make a 36. Okay, so if x is 0, this would just be 2. If x is 0, this is -1. If x is 0, this is -3 squared. So I'm trying to add a multiplier in front, coefficient, to make sure I get to a 36. So what is all of this put together? Did you get -18? So therefore A is what number? -2. So there you go. So now I can fill in the full equation with the coefficient and then all the factors. Did you know it was negative before we even did the math? Because look at the shape that it was in. It's a negative shape. Okay, write equation for a polynomial that has an x-intercept at 5 with a multiplicity of 2. An x-intercept at -1 with a multiplicity of 2.
What is multiplicity?
The degree, like this, the double, like, or triple. If it had a multiplicity of 3, so this, multiplicity of 1, multiplicity of 2, multiplicity of 3. Okay, and then the range is from -infinity to 0. So this is a fourth right now. So it would look like this right now, right? That range would be what to what right now as it would sit? It'd be 0 to infinity, right? So I want a range that's -infinity to 0, right? So what do I need to do? I need to add some kind of negative value there, okay? And since there's no specific numbers, if you had written any negative value, that's acceptable.